Let's do the first one together. Okay, so a food truck sells gourmet burgers at local events. There are fixed costs of $1,200 to operate the truck, and each burger costs $5 to make. So the cost equation that we're given is CX is equal to 5X plus 1,200. All right, so again, this is all, right now they're not even talking about how much they're selling at all. This is just an equation for the cost of the owner of the food truck. So this is what the owner is spending. The owner spends, regardless if he sells anything or she sells anything, the owner of the food truck is going to pay $1,200 just to operate the truck. So what that means is like maybe rental costs, maybe just like buying the stove, the material, whatever. That's their fixed cost. They're going to spend $1,200 no matter what. And then on top of that, it costs $5 just to make the burger. So again, not to sell the burger, to make the burger. So on top of the $1,200 that the owner is spending, they're also spending $5 per burger. So maybe it costs $3 for the meat. And then if you think about the lettuce, tomato, all that other stuff, that's an additional $2 maybe. I don't know. But to make each burger, it's $5. Okay? So this is what the owner is spending. That's what I want you to understand. The owner that's trying to start this business, this is what they're spending. So now to answer the question, what is the slope of this equation? So they were able to represent this problem as a cost equation. And where do we get slope? Slope is at m value. So I could rewrite this cost equation like this if I wanted to. Oh man, where's the drawing? No, I don't want that. Oh, pen. Okay. So I know this is a linear equation because it looks very similar to this. Y equals mx plus b. Okay, but instead of this, I have c is equal to 5. I don't know what I did. 5x plus 1,200. So for the problem, we have a cost equation, and this is my cost equation, but it's very closely aligned, if not exactly aligned, to a linear function. This is a linear function formula or equation. This tells me that my function either looks like this or my function looks like this. One of these two lines, okay? So if I look at this and I match the values, 5 would be my m term, right? Because it's the number in front of the x variable. 1,200 would be my b term, also known as my y-intercept. So m is my slope. B is my y-intercept. And again, another way to think about y-intercept is when x is equal to 0. Y-intercept, this is when x is equal to 0. Why is it when x is equal to 0? So if I were to take this guy and set x is equal to 0, what would I get? I would get 5 times 0 is 0 plus 1,200. So when x is equal to 0, I just get 1,200. So again, this is why the b term, my b term is my y-intercept, because it's when x equals 0. So if I were to plug in 0 for x in this equation, I would just be left with this value, my b term. So again, if I'm aligning the equation to the equation that I'm familiar with, a linear equation, the number in front of the x is my slope, And whatever's being added or subtracted next to this value is my b term, which is also known as my y-intercept. So if I'm going to answer these problems, I would put my slope is equal to 5 and my y-intercept is 1,200. And we see that in the answer key, slope is 5, y-intercept is 1,200. Now, what does this mean if I were to interpret the problem? So the slope is 5. Again, we're talking about what the owner is spending, the cost that the owner is spending. So the slope would represent the cost per burger. This means that for each burger the food truck makes, the total cost increases by 5. So in other words, it's $5 for every burger that the owner makes. The y-intercept is just the constant or the fixed cost, so of just running the food truck. So regardless if they sell anything, the food truck has to spend 1,200. Again, I wrote as an example, this could be maybe permits, ingredients, labor. So even if they sell nothing, they still have to spend that 1,200. The C is asking if the food truck sells burgers at an event where 150 people order, what is the cost? So this is telling me to plug in 150 for X, because now it's saying I'm actually selling a number value. Okay, and 150 people, I'm assuming, is going to order 150 burgers. So what am I doing? I'm plugging in 150 for X. So I have C of X is equal to 5X plus 1,200. But now I know what X is. X is 150. So we have 5 times 150 is 750 plus 1,200. The total cost is going to be 1,950. So that C problem is just telling me to plug in X, evaluate for X, to get my total cost for a number of burgers or a number of people that are going to order. So again, if I interpret this problem, I'm just answering the question. So after I do the math, then I want to read the problem again just to answer the question. So the food truck sells burgers at an event where 150 people order. What is the total cost? If the food truck sells 150 burgers, the total cost of operation will be 1,950. How many burgers can the food truck make while keeping the total cost no more than 2,500? Okay, so this is kind of tricky. So because it says no more than, or at least are indications of an inequality problem. So that's where we have those little Pac-Man symbols. So saying no more than 2,500. So I know 2,500 for sure. Okay, so now I got to figure out, and then it's being in relation to my cost function, right? So now I'm just going to think about this problem in a small scale. So the cost can be no more than 2,500. So that means less than 2,500, but no more than could mean it could also be equal to 2,500. So that's the max. 2,500 is the max, so it could be equal to 2,500, but it cannot be any more than 2,500. So maybe this would be good to add in your cheat sheet, no more than. Is referring to this setup. Again, an inequality. If I say something like at least, so what I like to say when I say at least, I like to think about, it's kind of funny, but you could say, at least give me $20. So we could think of 2,500 as my $20, right? At least give me $20. That means that do I want anything less than $20? No, that means give me at least $20. Give me $20. And if you want to give me 40, go ahead and give me $40, but at least give me 20. So again, if I think of at least as cost, if I think of at least as a cost function, okay, in relation to cost, I mean, then I'm saying give me more, or at least the 2,500. So again, these are good things to write in my cheat sheet. So if I say no more than 2,500, that means, okay, my cost has to be no more than, less than, or equal to 2,500. No more than means less than or equal to. At least means more than or equal to 2,500. So for this problem, it's saying, okay, how many burgers do I need to sell so that my costs are no more than 2,500? So do we know our cost function? Yeah, we know our cost function. Our cost function is what? C of x is equal to 5x plus 1,200. So I know this is my cost function. So I can replace cost with just the function, which is the equation that's given to me. So I'm going to go ahead and erase. What did I do that for? Okay. I'm going to erase the c of x. We don't need that, because we already know cost equals this. Just the equation that's given to me, right? So now this is the same setup. My cost has to be no more than 2,500. And then I'm just solving for x, because I want to figure out, okay, how many burgers do I need to sell so that I reach this max limit? So all I'm doing is solving for x. So now, how would I solve for x? Minus 1,200. I want to get x by itself. That's my goal. So I notice that 1,200 is next to the 5x. My goal is to still isolate that x. So I'm just taking my time, going through my steps just to get x by itself. So now I have 5x is less than or equal to 1,300. And again, my goal is to isolate x. I'm trying to figure out how many burgers I would need to sell to reach my max limit. Okay. Notice I don't have to flip the sign because I'm not dividing or multiplying by a negative. So that Pac-Man symbol is still staying the same. So now I got x by itself. X is equal to, I got to plug this in my calculator. But if I look at the answer key, it's going to tell me the answer to this problem. So again, we see the setup. We're solving for x. So if I divide 1,300 by 5, I get 260. So what this is saying is I have to sell, or x can be no more than 260. So the max amount that I can make of burgers to not exceed 2,500 costs is 260 burgers. So the max amount of burgers I could sell, to answer the question, how many burgers can the food truck make while keeping the total cost no more than 2,500? 260 burgers. Because once I make 260 burgers, I'm right at 2,500. So I can't make any more burgers. I can make less burgers, but not more than 260. So find the implied domain. Okay, so again, think about the word problem. What are we talking about? We're talking about cost, right? And we're talking about number of burgers. So can x, when I plug in x, can x ever be negative? Can I have a negative amount of burgers? No. Can my total cost ever be negative? No as well. So to represent that x cannot be negative, I would just write x has to be greater than or equal to 0. So x can't be negative. In other words, x has to be greater than or equal to 0. X can be 0 because can I sell 0 burgers? Yeah, I can sell 0 burgers. If I plug in 0 for X, what do I get? Just the y-intercept, right? 5 times 0 is 0 plus 1,200. It's just the y-intercept. So that just tells me that if I sell 0 burgers, my total cost as the owner of the food truck is going to be 1,200. So I can sell 0 burgers, but I cannot sell negative amount of burgers. So we got to be careful with that, because that's just thinking logically. Again, domain, we look at different scenarios, right? We look at, do I have a square root? Do I have a fraction? In this problem, I don't have a fraction. I have a linear equation. So usually with a linear equation, y equals mx plus b, like my cost function, the domain would be all reals, but we got to think about it logically now. I can't have negative burgers. So the implied domain is just telling me, okay, I have to think a little bit logically. X cannot be negative, so I would represent that like this. X has to be greater than or equal to 0. And if I were to write this in interval notation, I could graph this on a number line and see that it's 0 to infinity. Okay, moving on. Find the zeros for this quadratic, okay? Notice, why is it a quadratic equation? Because the highest term, which is x squared, the exponent is 2. So that makes it a quadratic function. So if we go to the guide, we have different ways of solving quadratics. These are all quadratic equations. Why are they quadratic equations? Because they're all in the form ax squared plus bx plus c. But again, if you notice the problem that we're given, do we have this bx term, which is just x to the first power? No, we're actually missing this term. So what we have is ax squared and c. We just don't have that bx term. So notice in all these factoring problems, we have that bx term. We have the bx term, we have the bx term. And even with when we have to use a quadratic formula, we still have that bx term. So what happens when we don't have the bx term? So just like the problem that's given, we don't need a factor. Instead, what we do is we basically set the x squared equal to the number. Okay? The number that's given. So if we go back to the problem, we have x squared minus 30. So 30 and 14, they're basically c terms that we could combine. So what I want to do is I want to isolate that x squared and set it equal to my c term. And again, instead of factoring and using the quadratic formula, all I have to do is use the square root property, which is this essentially. The square root property tells me to take the square roots of both sides, and if I do that, then I have the positive and negative version of that side. So let's do this work on the whiteboard. Let me see if I could clear. Okay, perfect. Okay, so we have x squared minus 30 equals 14. So again, since I don't have, oh my God, since I don't have that bx term, since I don't have this middle term, I'm basically just doing ax squared equal to c, and then just solving for x. So that's what I'm going to do. I'm going to get all my c terms, so that individual number, all on one side together combined. So I'm going to add 30. Again, my goal is to isolate that x. So I want to get x by itself. So I have x squared is equal to 44. Okay, now that this is the case, I get to use the square root property. Okay? And again, my goal is to solve for x. Just like when I solve or just like when I factor or anything, my goal is always to solve for x. So look, solution set is x equals blank and blank. X equals blank and blank. Because I have a quadratic, then I have an x equals something. So I'm solving for x still. So I take the square root to both sides. And what happens when I take the square root to both sides? Remember, I get x by itself, which is the goal. But now I get x is equal to the positive and negative version of that side that I square rooted. So going back to the problem, I have x by itself. But now I don't have just square root 44. I have the positive and negative version of square root 44. Okay, so now why is that? Why do we, in the square root property, why do I have the positive and negative version of square root? Well, because let's say I wanted to solve for a simpler problem where I think it shows y clearly. Let's say I have x squared is equal to 4. Now, you can tell me just by looking at this problem that 2 squared equals 4. So even if I don't solve for x, I know 2 squared equals 4. But also keep in mind, what else squared equals 4? Negative 2 squared also equals 4. So if I do 2 times 2, I get 4. If I do negative 2 times negative 2, I also get 4. So that's why we have that positive and negative version. So again, if I were to solve for this, I get x is equal to the positive and negative version of square root 2. I mean, oh my God, the square root 4. And then if I were to simplify this further, I would see that I have the positive and negative version of 2, which is 2 problems, right? It's saying x equals 2 and x also equals negative 2. So I have 2 solutions for x. Notice I have the positive and negative version. Okay? So that's the same case here. Anytime we take the square root to both sides, once I isolate that x on this side, I have the positive and negative version. And just like I simplified the square root of 4 to 2, we can simplify square root 44 a little bit. So now I want to choose factors of square root 44 that have a perfect square. So what are some factors of square root 44? 11 and 4. The reason I chose 4 and 11, and I think those are the only 2 factors of square root 44 that I could think of at least. Yeah, that I can pretty much 22 times 2. That's another one, but that one's not going to help me because I want a factor that is a perfect square. So the reason I chose 4 and 11 is because square root 4, what is square root 4? Simplify to a nice integer 2. So 4 is a perfect square. That's why it's a perfect factor for square root 44 to choose in order to simplify my square root here. Okay, makes sense? So x is equal to the positive and negative version of 2 square root 11. Again, this is 2 problems, just like it divided here. It's saying x is equal to 2 square root 11, the positive version, and x is equal to negative 2 square root 11. Okay. Just recapping, again, this is a quadratic equation, and I could solve for x. But it's just not in a traditional sense. Why? Because I don't have bx. So because I don't have bx, I'm basically just setting the x squared equal to c, and I'm solving for x. And when I solve for x, I have to take the square root of both sides, which indicates that I have to use the square root method, which tells me that I have to Once I get x by itself, I really have the positive and negative version of this side. Okay, number 3. Okay, the vertex problem. Find the vertex for this quadratic equation. So the first thing I want to do is I want to label, this is what I was talking about, ax squared plus bx plus c. So now I know I have a quadratic equation because I have an x squared, and what I notice is I have a bx. Do I have a bx here? Yes, I do. Unlike that other problem, I actually have this middle term. Okay, that negative 10x. So I have my bx term. Because I have these values, I could solve for the vertex, okay? This is a U problem. This is a problem that looks like a parabola, either a parabola going up or a parabola going down. That's what I got to figure out, okay? But I definitely have a vertex. I just don't know where. In order to solve for that, I have to define all these values, A, B, and C. So we're going to go ahead and do that. Negative x squared minus 10x plus 24. Negative x squared plus 10x plus 24. Let me double check. Negative x, oh, minus 10x plus 24. Okay. Okay. So again, if I align this with the standard form of a quadratic equation, so this would be the standard form, ax squared plus bx plus c. Okay, which values are which? So a is just the number in front of the x. So what number is in front of the x squared? Just like this guy. A is equal to, I don't know why it keeps on erasing. A is equal to -1. Do you see that? It's just a number in front of x squared. So it's not -1x squared. It's just the number in front of x squared. So now, what's my b term? Again, the number in front of the x. So, and I got to be careful because I see a negative. So it's not just 10, it's a negative. Okay. I think I see what's going on. It's a -10. And then my c term is just that final value by itself with no x attached to it. That's my constant. So I have a plus 24, so a positive 24. So now I know what A, B, and C are. Okay? Now, to solve for my vertex, what am I solving for? That's what I want. I want to know what the vertex is. Okay, again, the vertex is just either the peak or the valley, the highest point or the lowest point. So I have a quadratic equation, right? Ax squared tells me that I have a parabola, either a u going up or a u going down. The vertex is this point or this point, depending if I have a u going up or u going down, but it's either the lowest or the highest point. So I got to solve for that vertex. That vertex is defined as h comma k. And the first thing I need to do in order to solve for the vertex is solve for my h value. So the formula for that is h is equal to -b over 2a. So I have to be careful here when I plug in my points, okay? So what I would do, since I know I'm plugging in values B and A, right? Because we have those values, A, B, C, we just defined them. And that means I'm plugging them in where they go. So since I'm plugging values in, I want to keep the integrity of the problem, because what I mean by that is that minus I needs to stay there, okay? Regardless of what B is, that minus sign needs to stay there. So this is how I'm rewriting my problem. It's the same problem. What I'm trying to make you understand is that when I plug in for B, okay, all I'm doing is I'm erasing B and plugging into the parentheses. That way I don't mess up the equation. So I'm plugging in B here, and I'm plugging in A here. All I did was put parentheses around the values to remind myself to keep the minus there. So what is B? My B value is -10. All right, so this is why I highly recommend you put parentheses around it, because it's very easy to mess this up. It's a minus times a -10. And 2, I'm plugging in A, which is equal to -1. Okay, so this is not 2 minus 1. This is 2 times a -1. 2A means 2 times A. Negative B means -1 times B. So right now I have a -1 times a -10. So what does this simplify to? I have -1 times -10, so that's a +10. A negative times a negative gives me a positive. And 2 times -1 is -2. So H is equal to 10 divided by -2, which is -5. So I just solved for my H value. So right now, as far as the vertex, I just solved for H. So I can plug in H there. And I still need to solve for K. In order to solve for K, all I do is I plug in -5 into the original formula. Oh wow, didn't realize I used this much space. But into my original function. So I'm going to plug in -5 for x essentially. So what I'm doing is f of -5. That's just telling me I'm evaluating for x, -5 for x, is equal to negative. Okay. Again, all right, what I'm gonna do first, just so you could see what I'm doing. I'm gonna write the original problem, then I'm gonna show you me plugging in for x, because again, a lot of mistakes happen here. So I have f of x. My original function is f of x is equal to negative x squared minus 10x plus 24. Okay. Again, just like what I did with negative b over 2a, what did I do before I started plugging in values? I put parentheses around the letters, so I remind myself to plug in and keep the integrity of the problem. Okay, so what I'm going to do before I plug in -5 for x is I'm going to put parentheses around my x values. So I put a parentheses around that x, and I'm going to put a parentheses around that x. Okay, so now I'm going to plug in -5 for x. Make sense? Minus 10 times negative 5. Again, that means times. Plus 24. Okay. Okay, now this just becomes a simple problem with order of operations. So which one do I want to do first? So again, PEMDAS tells me the order of operations. PEMDAS, P stands for parentheses. So I'm going to look at all the parentheses and see if I could simplify anything within the parentheses. If there's any math that needs to be done. Can I simplify negative 5 even further? No. Can I simplify negative 5 even further? No. So what's the next thing I do? I look at where there's exponents. I have exponents here. So again, I'm not going to worry about that minus in front until I simplify the parentheses to this exponent. So what I'm going to do first is negative 5 squared, which is negative 5 times negative 5. So that gives me 25 that I'm going to keep inside parentheses. Okay, because I still have that minus attached. Okay, again, this is not minus a negative 5. It's actually negative 1 times negative 5 squared. So I simplified negative 5 squared first because there's an exponent there. And I still have negative 1 basically times 25. So now I have negative 10 times negative 5 over here. And then I have plus 24. Okay, so after exponents, I just simplified the exponent problem. Again, very important that I still have the parentheses. I do either multiplication or division at the same time. Doesn't matter. So wherever I see multiplication, I'm going to do. Here, there's multiplication that's happening. I have negative 1 times 25. So that is negative 25. Notice I was able to remove the parentheses because I actually completed the multiplication here. So I have negative 25, and then now I have negative 10 times negative 5. Negative 10 times negative 5 is plus 50. And I still have plus 24. So I have negative 25 plus 50 is 25. Then plus 24 is 29. 49. This equals 49. So f of negative 5 is equal to 49. Okay, so why did I do all that for? F of negative 5, when I plug in my h value, f of h, because again, negative 5 came from h, when I solved for h, is equal to k. So when I plug in my h value to my original function, I get my k value. So what does k equal? 49. So when I was solving for h and k, I finally found my k value. K is equal to 49. So this is the vertex. So again, this is that peak. This is going to be either this or this. So now, how do I know I have a u going up or a u going down? I already solved for this dot, but now I need to determine, how do I know if I have a max? This would be a max. If my u points down, that means my vertex is max. If my u points upwards, that means I have a min, a lowest point. My vertex, my lowest point. So now, how do I know if that is this way or this way? So how do I know what my vertex looks like? I look back at my value a. Since a is negative, so if a is less than 0, I have a u pointing down. if a is bigger than 0, so in other words, a is positive, then I have a u pointing up. So I have this scenario, right? Where a is less than 0. I have a -1, so a is less than 0. That means I have a u pointing down. So because I have a u pointing down, the vertex I just solved for is a max. So this value would be my max. Because my a value is negative. So again, if I go back to the answer key, we just solved for h and k, -549. It is the max point because a is -1, it's negative. So my parabola opens downward. And my max value would just be the k value, which is 49. So if it's asking for the value, it's 49, my k value. I have a max value at 49. Okay, now to answer B, it's saying, what is the axis of symmetry? The axis of symmetry, the formula for axis of symmetry is x equals h. So I just look at my vertex. Remember, vertex is hk. What's my h value? -5. So my axis of symmetry would be x equals -5. That's simple. Okay, what is the axis of symmetry like graphically? So if I were to graph the axis of symmetry, I'm going to draw the U a little bit bigger now. So I have a downward U. The axis of symmetry is just a line through my vertex. Okay, and again, in order to draw a vertical line, I have to have x equals a number. So in this case, I have x equals a number h, which is x equals -5. So x equals -5 gives me a vertical line at x equals -5. So my axis of symmetry is this line that basically cuts my parabola in half because it cuts through the vertex, and the vertex is exactly that half point of my parabola. Okay, what is the x-intercept? So y-intercept is when x equals 0. My x-intercept is when y equals 0, and I believe that is in our learning guide that I also attached to you. At y-intercept is when x equals 0, so that's why my b term, I'm able to solve for that. My x-intercept is when y equals 0. So when I'm solving for my x-intercepts, okay, what do I have to do? These are the steps I must follow. Everything on one side, set y equal to 0. So I'm going to go ahead and do that for this problem. This is my function, right? Negative, here, actually, let me do some more space. Negative x squared, f of x, is equal to negative x squared minus 10x plus 24. So everything is already on one side, okay? What on one side just means on the same side of the equal sign. So everything's on one side already. I just got to set it equal to 0. So that's what I'm going to do up here. Set my function equal to 0. So I have negative x squared plus 10x. Wait, plus, oh no, minus 10x. Minus 10x plus 24. Okay. And I'm set, everything's on one side, cool. I set everything equal to 0. Okay, the first thing I want to do is I want to get x squared by itself. So right now I have a negative x squared. I don't want to have that negative in front. Okay, so just like if I had negative 2x, for example, I don't want to have that -2 in front of it. So I would divide everything by -2. So that's exactly what I'm going to do here. I'm going to divide everything by -1. If I had a 2 in front, then I'd divide everything by -2. Okay, but right now I'm just dividing everything by -1 because I want to get x squared by itself. So really what this does is it divides every term individually by 1. So I have -x squared divided by -1. Then I have plus -10x divided by -1. Then my last term is 24, right? Then I have 24 divided by -1. So me dividing everything, the whole function by -1 is like me dividing every single term by -1. So -x squared divided by -1 takes away that negative sign. So it just becomes positive x squared. And the reason I'm able to do this is because, again, whatever I do to one side, I do to the other side. So dividing by a negative over here, I have to divide by a negative over here. What's 0 divided by -1? It's just 0 again. So I still have 0, but now I have 0 is equal to positive x squared. Then -10x divided by -1 is now positive 10x. Again, negative divided by a negative gives me a positive. But now 24 divided by -1. Positive divided by a negative is now a -24. Negative divided by negative, positive. Negative divided by negative, positive. Positive divided by a negative is negative. So I've just changed my problem to this. I'm able to do that again because I'm dividing both sides by -1. 0 divided by -1 is equal to 0 still. And just like I mentioned here, if I had a 2x and I divided by a -2x, for example, because I had a -2 here, 0 divided by -2 is still 0. So that's why I'm still able to do that. Okay, so this is what I have now. I have 0 is equal to x squared plus 10x. Let me erase. Actually, let me just write it up here. 0 is equal to x squared plus 10x minus 24. So 0 is equal to x squared plus 10x plus 24. Okay, now this just becomes a factoring problem. So again, if I look at my learning guide, after I do that, okay, I can try to factor. So what are factoring? First, I factor out the GCF. That's what I basically did. I factored out the -1. Okay. Then case 2, I see if it's an easy trinomial. So how do I know it's an easy trinomial? When the x is by itself. Okay. Here, I have this scenario now. Now that I've taken out the -1, notice I have x squared by itself. So right now I have case 2 scenario where I have x squared by itself. Now that I have x squared by itself, it becomes an easy trinomial, which means I should be able to factor into 2 parts, x plus or minus something times x plus or minus something. I just got to figure out these values. How do I figure those out? Again, I look at my C term. I look at factors of my C term. What times what gives me my C term 6 in this case? Oh, 2 times 3 gives me 6. Or 3 times 2 gives me 6. Or -2 times -3 gives me 6. But now I look at factors of 6 that add up to my B term 5. Notice 2 times 3 equals 6, but also 2 plus 3 gives me 5. So that's exactly what I'm doing here. What are factors of 24 that when I add them together, I get 10? Well, factors of 24 are 12 and 2, right? But Is 12 plus 2 going to give me 10? No. Only 12 times negative 2, that's negative 24, so I can't use that, but that would give me 10, right? 12 plus minus 2 would give me 10, but that doesn't equal 24. It equals negative 24, so I can't use that. Another option is 6 times 4. That gives me 24, and 6 plus 4 gives me 10. So I just found factors of 24 that when I multiply them, I get 24, and when I add them, I get 10. So I have x plus 4 and x plus 6. I still have this equal to 0. So now that I'm able to factor this out, I can set each factor to 0. So I basically have x plus 4 equals 0. And I have x plus 6 equal to 0. And now I just individually solve for x. So I want to get x by itself, so I have to subtract 4 minus 4. So now I have x equals negative 4 and minus 6 minus 6. I have x equals negative 6. Okay, so the point of this is what I just used essentially is called the zero product property. Zero product property just says 0 is equal to a times b. So if a is equal to 0, my entire function is equal to 0. If b is equal to 0, then again, my entire function is equal to 0. So that makes sense, right? Because if I plug in negative 4 here for x, negative 4 plus 4 gives me 0. And then I have negative 4 plus 6 gives me 2. So really I have 0 times 2. Anything times 0 makes the entire function equal to 0. Now if I plug in negative 6 for x, then I have negative 6 plus 4, which is negative 2. And then if I plug in negative 6 plus 6, that is 0. So I have negative 2 times 0 again. So that just means anything times 0 gives me 0. So that's why we solve for x individually for each parentheses, basically, each product. These are my x-intercepts. So this translates into negative 4. Again, when I plug in x equals negative 4, what do I get? I get 0. Negative 4 plus 4 is 0 times whatever this is. Anything times 0 is 0. So my y is 0. X-intercepts is when y is 0. That's why in my first step, what did I do? I set y, my function, equal to 0. That was the very first thing I did because I want to find values of x that make my y 0. When x is equal to 6, again, my y is 0. My function is 0. I could check for it if I wanted to. I could plug this into my original function, which is this guy. I could plug that in here, and I would get 0. Okay, because this is equal to this factor form, and when I plug in these values, it's very clear that I get 0. So these are my x-intercepts. Okay, so on a graph now, if I were to think about this graphically, I have negative 6, 0, and negative 4, 0. So I have negative 6 and negative 4. Let's just say they're there. This is very small scale, negative 6, negative 4. X-intercepts, again, are on my x-axis. That's why I'm drawing them here. Okay, and then what's my vertex again? Negative 549. So negative 549 would be, this is negative 5. let's say 49's here. Again, this is like a rough graph, but this would be my vertex. And then I have a U, right? So I have a U crossing at this x-axis and at this point on the x-axis. Oh my God, I missed it. But at this point in the x-axis. And then we know what my axis of symmetry is, right? It's x equals -5, which means I have a vertical line at x equals, I keep missing the point, but x equals -5. So this is what I know so far of my function. Now the next thing it's asking for is, I forgot I have a -10x. Okay. The next thing it's asking for is is the y-intercept. So when I solved for my x-intercept, I was solving for y equal to 0, right? I set y equal to 0. For my y-intercept, I set x equal to 0. So all I'm doing is I'm plugging in 0 to my original function. So I'm going to write down my original function. Or actually, I'll just show you here. This one's pretty simple. My original function was what? F of x is equal to -x squared minus 10x plus 24. If I plug in 0 for x, I have 0 squared, which is 0, times -1. 0 times -1 is 0. Minus 10 times 0, which is 0. So I have 0 plus 0 plus 24. F of 0 is equal to 24. So my y-intercept would be 0, 24. So again, if I were to graph this now, oh, I didn't want that color. It should be, yeah, 0, 20. Oh, I didn't want that there. Then I'd have it going through my y-intercept as well. Sorry, I got distracted. Okay. Again, when I think about domain, okay, if I look at my original function, what's my original function? It's lagging a bit. Okay. It's -x squared minus 10x plus 24. If I look at this function, do I have any kind of fraction? No. So I'm not worried about the denominator equaling 0, right? Because there's no fraction. Are there any square roots in this problem? No. So what is my domain? If I don't have those two problems and I don't have to think about it logically because it's not a word problem like the food truck, what is my domain? My domain is all reals. There's no restrictions at this domain. So that's why I write -infinity to +infinity. Now, so that one's asking about domain. Now it's asking for, did I go to the next problem? Oh yeah, this is the second. So I gave you another practice problem, problem 3, very similar, but in this case, I have a -4x, so not just -x squared, I have a -4x squared. Very similar still, very similar steps. Okay, so domain is all reals. And now, because I have a max value, right, I have a u, and the vertex is the highest point. So range, how do we read the graph again? We read it low to high. Right? This is my graph, low to high. So notice I can't put a line through the arrows, right? I can never bound arrows. So what's my lowest point? -infinity. And what's my highest point? Am I able to draw a line through this point? Yes, I am. It's my highest point. There's no arrows going here. And I already established that this is my max point. So what's my y here? 49. So I have -infinity comma 49. And because I have negative infinity, I use parentheses. And because I have a closed circle point here at 49, I use bracket. Oh, I meant to share my screen here. Sorry. I'll repeat myself. Oh, I meant to share this tab. Again, my lowest point, I can't bound the arrows, so my lowest point is going towards negative infinity, right? And I always read the range from low to high. So negative infinity to, what's my max point? My vertex is my max point, which is 49. I could draw a line through this point because it's my max point and it's a point. There's no arrows going in this direction. So that's why I have negative infinity, comma 49. So when I have a parabola like this, my range is always going to be negative infinity to whatever my k value is. So this might be good to write on my cheat sheet as well. Okay, so notice what's k? 49. If I have a parabola that looks like this, where I have, instead of a max, I have a min. Then I would have what? What would be my lowest point? K would be my lowest point. And again, I can't put a line through the top, so that means it's going towards infinity. And then it would be k bracket, because at my vertex I have a point. I have a point here and I have a point here. Just like this graph, I have a point at this max. So this might also be good to write on your cheat sheet. When I have a max point like I do now, I go negative infinity to k, in this case 49. K is 49. If I have a min, then I have k brackets infinity. I could also analyze domain, not just looking at the function. I could analyze domain here. Again, reading the graph left to right. Is this my leftmost point? No. X-intercept is not my leftmost point, because I technically have, even though it looks really narrow, the arrows are going slowly more left. Okay, so there's still more graph going this way. So really my max point is negative infinity. Same thing here. My graph is extending past this other x-intercept, going towards positive infinity. Or you can think about it as the function as well. Okay, so there's two ways to think about it. My domain is negative infinity to infinity. My range, reading the graph low to high, is either going to be, depending if I have a max, negative infinity to k, or k to infinity. If I have a max, like I do now, it's negative infinity to k. That's why my range is negative infinity to 49. Okay. Oh, no, I didn't want to share this. Share this tab instead. Okay. Over what intervals is the function increasing? So this one, I kind of want to use my domain to help me a little bit, all right? Because I want to read the graph left to right. So again, if I look at this graph, again, I'm going to scan it left to right. So if I'm scanning it, what is my graph doing? If I follow the graph going left to right, what is it doing? Which way is my scroller going? It's going up, which means my graph is increasing. So it's increasing, then it decreases. So from where to where is it increasing? It's increasing from what? Negative infinity. Again, I read it like my domain, left to right. Negative infinity to, where does it stop increasing? When right at my vertex, right? So I'm also going to write that too. When I have a max, my graph increases, and I read it like domain. So instead of thinking k like the range, my graph increases from negative infinity to my h. I don't have to write brackets for these guys. Okay, these are just parentheses. If you do, that's not, I won't dock points for that, but it's because at k you can't really say it's increasing or decreasing, so that's why we don't even include it. To my h value. So negative infinity, it's increasing from negative infinity up to my vertex when x is -5. So increase would be negative infinity to my h value, -5. That's the break point. That's the peak. And then from that peak on, it decreases. And this is always going to be the case. I'm always going to increase from negative infinity to h if I have a max, right? Negative. We could see the increase here up to my vertex h, then decrease. If I have a min, it's the opposite. So where's my graph increasing now? From h to infinity. If I have this case. Because again, if I follow my graph left to right, it's decreasing, then at this vertex, it starts to increase. Okay, so from here on, it's increasing. Okay, so for this graph, it's increasing from -3 to -5. Okay, again, problem 3, I have 2 examples, but it's very similar to that last problem 3, so I'm not going to go iterating the same thing. Okay. Okay, so now we have practice problem 4. Determine the quadratic function whose vertex is 3, 5 and passes through the point 6, -13. So if I have a vertex is 3, 5, let me write that down. Let me clear this tab now. Negative, oh wait, is it -3, 5 or 3, 5? It's 3, 5 and 6, -13. 3, 5. Oh my god, that looks horrible. Sorry, 3, 5 and 6, -13. All right, these are the points that are given to me. I just have to be careful how I label them. So it's saying, the problem, I'm going to read it again. It says, determine the quadratic function whose vertex is 3, 5, and the point is 6, -13. So which one is my vertex? 3, 5. And how do we label vertex again? If I think back to my last problem, I always label my vertex HK. If I'm given a point, my point is always, like this one, X, Y. So just be careful which one's the vertex and which is just the point. Then it becomes very simple here on. We want to use the quadratic function. All right, so in order to be successful at this problem, you need the quadratic function formula. So what is the formula? This guy right here. Vertex form of a quadratic function is y is equal to a times x minus h squared plus k. So let me go ahead and write that down. Y is equal to a times x minus h squared wait, let me see, x minus h squared, oh, plus k. All right, this is the formula I'm using. Notice, the first thing I need to do is plug in the points that are given to me and solve for a. That's the very first thing I do. I want to solve for a. Once I have a, again, very simple. So this is why it's very important to label these points correctly, because otherwise you mess up the formula. So what's my y value? I just labeled it. The point that's given to me, not the vertex, the other point that's given to me is just x and y. The vertex is h and k. So my y is just -13. Now again, a good habit to do before I plug in values is to put parentheses around each value that I'm plugging in. I'm not plugging anything in for a, that's actually what I'm solving for, but I'm plugging in x, right? I'm plugging in h, so parentheses around h. I'm keeping the square, and I'm plugging in something for k. All right, so what's my y? -13. I don't know A. Again, I'm still solving. My goal is to solve for A. That's why I'm plugging in all these other points. What's X? Again, I'm not looking here because this is H and K. What's X? 6. So I'm plugging in inside parentheses there, 6. What's H? Okay, now I look over here, 3. And what's K? I look over here, it's 5. Okay, now I try to simplify this out a little bit. Simplify it. I have negative 13 is equal to A. All right, can I simplify 6 minus 3? 6 minus 3 is just 3 squared plus 5. Okay. I'm going to simplify 3 squared to 9. So I have 8 times 9. When they're next to each other, it means times. That's why I put parentheses. All I did was simplify 3 squared to 9, and I still keep it in parentheses to emphasize that it's still being multiplied. Plus 5 is equal to negative 13. Okay? I'm solving for A, so I want to isolate the A. So I'm going to move 5 over here. I'm going to subtract 5. Subtract it. Now it's gone from that side. Whatever I do to one side, I do to the other. Negative 13 minus 5 is negative 18. Is equal to 8 times 9. 8 times 9. Again, I want to isolate the A. So if I have 8 times 9, I'm going to divide by 9. Boom. To both sides, not just one side. So I have negative 18 divided by 9 is negative 2 is equal to A. All right, I solved for A. Again, how did I solve for A? I used the formula, the vertex form, quadratic form formula, y equals A times x minus h squared plus k. And I was very careful of how I labeled hk the vertex. This is my vertex, so it's hk. And the point that's given to me is 6, negative 13, which I label xy. From then on, everywhere I see a value, I put parentheses around it, so I'm very careful at how I evaluate at that point, okay? Because let's say I have x minus h and h was negative 3. Then I'd have to plug in negative 3 here. So really I'd have 6 plus 3, not 6 minus 3. That's why I emphasize putting those parentheses so I don't mess up and keep the integrity of the equation. That minus stays minus. Okay, I solved for A. So now after that, after I solve for A, I need A equals, and I need the vertex. So I already know, I just solved for A. A equals negative 2. And what's the vertex again? 3, 5. I only need these two values to get the final form of the equation that I'm looking for. So again, I'm going to use this formula again. But now I'm not solving for anything anymore. All I'm going to do is finally plug in these last values, and I have the final form that's being asked of. Y equals A times x minus h squared plus k. Okay, so now I'm not plugging in values for for x and y, just h, k, and a. That's why I only need these values. I solved for a. That was the whole point of doing this work. I solved for a. Now that I have a, I just need my a and the vertex to finally fulfill the equation. So a is equal to negative 2. Again, I'm not putting in anything for x. I'm not touching x and y. And then h is 3, so I plug in 3 there. Not negative 3, it's 3. That's why I still have minus. Minus 3 is h. Plus k. What's k? 5. And this is the final answer. Okay, moving on. All right, that's what this work is saying. Write the function in vertex form. This is the final function in vertex form where I have an A and I plug in H and K. Okay, now with these, let's see how many are left. Okay, this one we did in class. I don't think I can do all of these problems. These I kind of do want you to review some of them on your own, okay? But, or if you have any questions with these, then you can email me later, okay? Because I kind of ran out of time today. But I'm gonna do these last, these two, 5 and 6. Maybe another time if we have time, I could go over 7 and 8. All right, but I'm gonna go over 5 and 6 now. All right, so we have an inequality. All right, so with inequalities like this one, we want to isolate the absolute value sign before it divides into two problems. Okay, so we'll see that right now. So right now I have 3 plus 3x plus 4, or 3 plus absolute value 3x plus 4 is less than or equal to 15. So let me rewrite it here. 3 plus 3x plus 4. 3 plus absolute value 3x plus 4 is less than or equal to 15. So again, I want the absolute, I want to get the absolute value by itself. So these lines I want to get by itself. So in order to do that, I notice that 3 plus is in the way, right? So I'm going to move it out the way. Again, whatever I do to the left, I have to do to the right. So I just moved it from here to here by subtracting. So in order to eliminate plus 3, I'm subtracting 3. So now I have the absolute value sign, 3x plus 4 is less than or equal to 12. Okay, now that I have the absolute value by itself, it divides into two problems. Okay, in order to remove the absolute value, once I remove it, it divides into two problems. One is basically essentially the same thing without the absolute value. So one of the problems is just 3x plus 4 is less than or equal to 12. That's one problem. Again, just basically just erasing the absolute values, that's one problem. And then the other problem is, again, 3x plus 4 without the absolute value signs. But now it's 3x plus 4, and I flip the sign, and I make this number negative, or the opposite. So if it's plus 12, that means minus 12. So these are the two things that change. Again, this divides into two problems. Flip the sign, make this negative. And then all I do is solve for x. Very simple. Minus 4, minus 4. So I have 3x is less than or equal to 8. Divide by 3. Again, I'm just isolating. I'm solving for x. X is less than or equal to 8/3. Done. Same thing over here. Minus 4. Minus 4. 3x is greater than or equal to negative 16. Divide by 3. Divide by 3. X is greater than or equal to negative 16 over 3. Okay, now we can graph it. Now we can graph these points on the number line. All right, when I graph these points on the number line, I have two scenarios. I either have this scenario, again, open or closed, doesn't matter. One could be open, one could be closed, or they can both be closed or both be open, doesn't matter. But I have either, this is a in between. Okay, I'm not gonna spell that out, but in between, or I have this scenario. I have to watch out. Okay, I gotta be careful what scenario I have. Again, these circles could be open or closed depending on the problem. But what are these scenarios? Okay, so I gotta be careful. So which one? When I write 8/3 and -16/3, I also have to write them like how I would in order, how they would actually appear on a number line. So -16. Is it really negative? Oh, yeah, -16, yeah. And 8/3. Okay, this is negative infinity. This is positive infinity. Okay. At 8/3, do I have an open or closed circle? Well, I have equal to, so that means including 8/3, so closed circle. I have -16/3. Again, I have equal to, so that means including. Now at -16/3, which way is my tail going? It says x has to be greater than or equal to. So greater than or equal to means this way. I'm not going to finish it until I know what this one's going towards. Here it's saying x has to be less than or equal to 8/3. So it is meeting, they're meeting each other. This is a scenario where they meet each other. But sometimes it's not that. Sometimes it's going this way. So you just got to make sure when I draw it, I'm careful of which way the tails are going. Okay, so now if I were to write this in interval notation, what's my leftmost value? I read it from left to right. So my leftmost value is -16/3, and my rightmost value is 8/3. They both have brackets because I both have closed circles at these points. Okay, very similar to this problem is the next one, where it's just a word problem, but I'm still given an inequality. I just got to make sense of the word problem. But what I would do is I would kind of ignore the word problem, solve for the inequality, and then try to answer the question. Okay? So that's exactly what I'm going to do. It's just saying, this is the inequality that I'm given. Let's just solve for it, and then we'll try to answer the question and make sense of the problem. But again, this is just another inequality problem. So I have 10. But notice I have 10 times the absolute value. When the 10 is next to these absolute value sides, it's multiplication. So I have 10 times absolute value t minus 70 minus 5 less than 15. Again, what do I want to do? I want to isolate the absolute value. So 10 times t minus 70, 10 times t minus 70 plus 5, I think. The library will close at 30 minutes. If you need assistance, oh no, minus 5 less than 15. Okay. So again, my goal is to isolate the absolute value. So right away, I could take away this 5. So add 5 to both sides. So now I have 10 times t minus 70 it's less than 20. Okay, now how can I eliminate that 10 times t minus 70? Divide by 10, right? Since it's 10 times this absolute, think of it like 10x. The absolute value is just x. So in order to isolate the x, I have to divide by 10. So in order to isolate this absolute value, I got to divide by 10. So divide by 10. So now this 10 is removed. So now I have 10 minus 70, absolute value less than 2. Okay. Once I remove the absolute value, it becomes 2 problems, just like the last problem. This one just involved a little bit more math, right? I had to add 5 and divide by 10 in order to isolate the absolute value. So just a little extra step just to isolate the absolute value, but it's the same goal. So now 1 is just exactly the same, just removing the absolute value, right? The other one has 2 differences. So I still have 10 minus 70. I mean t minus 70, but now I flip the sign and make it negative or opposite value, right? Flip the sign, make it opposite value. And I just solve for t. Plus 70, plus 70. I have t is less than 72. Over here, plus 70, plus 70. T is greater than 68. Oh, what am I doing? T is greater than 68. Okay, now I'm going to graph this on a number line just to see what I get. Negative infinity, infinity. Again, I could have one of the 2 scenarios in between, or they basically flare out. All right, so I have 68 and 72. I have open circles because they're both non-inclusive. There's no equal sign attached to the less than sign or equal or greater than sign. Then at 68, it's saying t is greater than 68. So I'm going to start moving my tail this way, and then now I'm going to see if they connect. T is less than 72. Okay, this is another scenario where that's in between, but just not inclusive at 68 and 72. So now let's make sense of the word problem. Saying, determine the temperature range that is considered safe for storing the chemicals. It says the ideal temperature for storing certain chemicals is 70 degrees. Now, the safe storage range can be determined by this inequality that we just solved for. That's why I suggested just solve for the problem, and then let's just see if we make sense of it. Where T is the temperature in degrees Fahrenheit, determine the temperature range that is considered safe for storing the chemicals. Well, this means that the chemicals must be stored between 68 and 72 in order for it to be safe, but not exactly 68 and 72, right? Because it's not including 68 and 72. That's why we have open circles at those points. The area problem. Okay, a farmer has 400 yards of fencing. So fencing is just something that I have to wrap around an area with. So we have to fence 400 yards and enclose a rectangular field. So if I'm going to draw this, get a visualization. So I have a rectangular, okay. I have a rectangular field. And again, to basically wrap around fencing around this field, I have 200 yards. So those 200 yards, since I'm wrapping around an area, okay, is my perimeter. I'm going to put P for perimeter. So this is what I'm given in the problem, that I'm wrapping around an area of fencing with 200 yards of my perimeter, okay? One side of the field borders a river and does not need fencing. Okay, so this is important as well. This side is a river. So do I need to put a fence there? Do I need to use 200 yards of fencing to enclose that part of the river? No, I do not. So what I'm dealing with is just one length, one width, and another width. This side I don't need to worry about fencing, okay? Just here, here, and here. So I'm going to use all 200 yards of my fencing to just enclose a width, a length, and a width. And I don't have to worry about this side because, as the problem mentioned, there's a river here, Okay. Now let's say I give you another word problem and there isn't a river. Then I would have another length, right? But because for the sake of this problem, we do have a river on that side, so we're not worried about it. Okay? So for the sake of this problem, this is specific to this problem where I have a river covering one side, then that just means I have two widths and a length. Okay? So why is that important? Because what does perimeter equal? Perimeter usually equals length plus width plus width, right? It's a rectangle, length plus width plus width, which simplifies to 2L plus 2W, right? 2L plus 2W. However, in this problem, so that's usually the formula for perimeter. If I am enclosing an entire rectangle, right? That's if I have a length here that I have to worry about. But for this problem, I don't have a length there, okay? So really what I am enclosing is similar, but only one length. Only one length, okay? So for this problem, I just have 1L and I have 2W. So that is my equation for perimeter. And since I know what P is, I can just fill it in there. Oh, what happened? Since I know what P is, I could just fill it in there. So really I have 200 is equal to length plus 2W. Again, I haven't even answered. I don't know what happened. I haven't even answered the problem yet. Okay, all I'm doing is setting up the work for my problem. So I have length plus 2W. Okay, so just by reading the problem that I'm covering and I'm fencing an area with 200 yards, but the area only involves two widths and a length because one side borders a river. Okay, so this is just me reading the problem, setting up my problem, or translating the word problem into an equation. Okay, but I haven't answered any of the questions yet. So now let's get into answering the questions. So it says, first thing, express the area of the field as a function of its width. Okay, so area of the field. So I want to fill out the area of the field as a function of width. Well, normally I know, just like I know how perimeter is just length plus width, area is equal to length times width. So I'm going to write that down. Okay, I'm going to write that down. Area is equal to length times width. Length times width always gives me the area. However, what is the problem asking for specifically? It says express the area of the field as a function of its width. Okay, so what that means is they want to replace the L as a function of width. So instead of having a area equals length times width, when it's saying as a function of width, they basically want area in terms of W. Okay, so basically what you want to think is, how can I change L so that in this equation there's only the variable W. Okay, so we don't want to have two separate variables or two separate like letters within one function. Okay, makes it messy basically. So it's just best to have the same variable for the entire function. So aka only have a bunch of W's in the equation. Okay, so how can we change the length so that it's a function of W, so that when we have area as a function of W, we only see W in the equation. So what we're going to do here is solve for L. And what you'll notice is once we solve for L here, for this, because remember, how do we get this? This is my perimeter equation. I'm going to use my perimeter equation, which is length plus 2W. I'm going to use this equation and solve for L. That way I could, once I solve for L, I'll be able to plug that into here. Okay, so let me just do it, and then you'll see why we do it. Okay, so I have minus 2W, minus 2W. So we have 200. The reason I subtracted W is to get everything on one side so that L is by itself, right? So it cancels 2W out here, moves it to the other side. So 200 minus 2W is equal to L. Okay, notice, instead of having length times width, okay, I don't want us to have two variables in an equation. It's only asking for area as a function of W. So that means only see W there. What else is equal to L? This guy. 200 minus 2W. So do you guys see how I use my perimeter equation? 200 is equal to L plus 2W. I solved for L so that I could write L in terms of W. Okay, so now that I know L equals 200 minus 2W, I can plug that in to my area equation. I still have length times width, but now I have area as a function of W. So instead of L, I'm going to put this guy, because L equals 200 in parentheses, 200 minus 2W times W. So I'm going to write that next to each other. They're being multiplied. Times W. Okay, now I'm just going to simplify my area function by expanding it. So just multiplying it out. Okay, so I have W times 200. I have W times 200, which is 200W. Then I have W times negative 2W, which is negative 2W squared. And again, I want this to be in proper form. So this is still correct, but usually we want the leading term. So again, what is the leading term? It's the term with the highest exponents. This equation has two terms, 1, 2. Okay, now to determine which one is the leading term, it is the term with the highest exponent. So 200W, this W technically has an exponent 1. We just don't write it because W1 is just W. Okay, this term has the exponent 2. So the one with the highest exponent, which is this guy, should go first because it is technically my leading term. So I'm just going to rewrite the problem by switching those two values. Again, when I put this value in front, I have to remember to also attach the sign. So it's negative 2W, not just 2W squared, it's negative 2W. And then this one has a sign, 200W is plus 200. There's no negative in front or subtraction in front. Okay, so I just rewrote the problem with the leading term in front. Now I have my area as a function of W, as a function of width. Okay, perfect. So I just solved for area. This is my length times width equation, my area. Okay, now one thing I want to point out here. So again, reminder of how I set up the problem. It's telling me I have a rectangular field that I need to enclose with fencing. So right away it told me, okay, the fencing is 200 yards. That's what I'm going to use. That's the amount of yards I have to, again, enclose, wrap around this area. Okay. For this problem, it says, so I know length, width, because I have a rectangle, right? For this problem, it says that the river is what borders one side, so I don't have to worry about fencing over here. That is why my perimeter is equal to length plus 2w, because notice, because there's a river here, we don't have to worry about fencing over here. But we still have to worry about fencing here, and fencing here. So what am I left with? 2w plus L is going to be equal to the yards that I'm going to use up. I want to use up all 200 yards, so I'm just going to focus on using up those 200 yards for this side, and this side, and not worry about this side. That side doesn't need fencing because there's a river there. Now, we have to be careful. That's for the sake of this problem. Let's say I just wanted to enclose a basketball court. Okay, is there any water involved here? No. If I was to enclose a basketball court, then I would need all sides to have fencing. Okay, so just be careful with the problem. This is just an example, so it might be a little bit different to what maybe would be expected on the exam. But if I have a basketball court, then yes, I would need length, width. So what would my perimeter equation be if there's no river involved? 2L plus 2W. I would need to enclose all sides. Okay, for this problem, I don't need to enclose one side. So that's why I have 1L plus 2W. Okay, so just really carefully read the problem. Okay, but if I have 2L, 2W, I could still solve for L just like I did here. Okay, so just pay attention to the problem. So now I have area as a function of W. Perfect. Now, notice that this is a quadratic equation, right? I have something close to the form ax squared plus bx plus c. This is my A. This is my B. The 200 is my B. -2 is my A. And then I just don't have a C term, but this is still a quadratic function, okay? Now, I'm highlighting this because if I look at the question, it says express the area. Okay, my bad. And then it says find the maximum area using the vertex formula, okay? So I can find max area of this equation because I have a quadratic function. So now, just like I find the vertex for any other quadratic function, I can find the vertex of this function. So now, why is it a max? It is a max because, again, what is my A term again? Now, A is the coefficient of the leading term. So the number in front of the x squared, in this case, w squared. It's -2. What's my B term? 200. And my C term is just 0, but I'll just label it there. C is equal to 0. There's plus 0 there, I guess. Okay. Again, what does the A tell me? I have a quadratic function, so I either have a u down or a u up, right? I have a parabola, I just don't know if it's pointing down or upwards. If A is bigger than 0, so in other words, if A is positive, what does that mean? I have a u up. But in this problem, my A is negative, so I have a u down. So what does that mean? What does that mean? That means my vertex is up here for this guy, and my vertex when A is positive is down here. So because A is negative, my parabola points downward, so that means I have a max. So that's why we're going to use the vertex formula. We're going to solve for this vertex because we want to find max area for the problem. Okay? So this is telling me I have a max because my parabola, it's a quadratic function. It reflects its quadratic function. And in order to solve for my max area, I have to solve for the vertex, okay? Because my vertex happens to be my max point. Okay, does that make sense? So how do I, for any quadratic, how do I solve for the vertex? I solve for the vertex with, and we denote it, or we label it, or we name it HK, okay? So first we solve for H, and the equation for H is negative B over 2A. Okay, so now we got to be careful how we plug in values again. I can't emphasize this enough. What I like to do before I plug in A and before I plug in B is I like to put parentheses around those values so I don't mess them up. So H is equal to negative B over 2A. Okay, the reason I put parentheses around the letter is because, first of all, it reminds me that I'm multiplying. Okay, I'm not adding 2 and A. I'm not adding negative and B. I'm not adding those values, negative 1 and B. I am multiplying. Okay, and another reason is because, so I keep the integrity of the problem. This reminds me that I still have a negative in front. For example, if B equals negative 2, then I would have negative 2. Okay, which means negative 2 times negative, which equals positive 2. Okay, so that, again, it reminds me that I'm multiplying, and it reminds me to keep the integrity of the problem, so not forget any of those symbols that are already part of the problem. Okay, so now what's B? I can fill in the parentheses. What is B? Okay, B is 200, so I'm going to plug in 200. And what's A? A is negative 2. So now I have negative 1 times 200 is negative 200. And 2 times negative 2 is negative 4. So this is equal to negative 200 divided by negative 4 is equal to 50. So this is, what do we solve for? Why do we do all that math? Because we're solving for H. So for H and K, I just solved for H and it's 50. Now I had to solve for K. Okay. Now, how do you solve for K? You solve for K by plugging it back into this equation. Okay. But, okay, so normally we're used to this X and Y. Okay. H and K is still a coordinate point. We just label it H and K just to distinguish that it's the vertex. Okay. But this is still an X and Y coordinate, meaning that when I get ready to graph this is still my X value. I would still go 50 this way, and then whatever K is up or down. Okay, so it's still a coordinate point, right? Because my vertex is a coordinate point if I graph it. But if I look at the problem, it's not negative 200x squared plus 200x. It's negative 2w squared plus 200w. Okay, so really my x is also labeled as a w. All right, does that make sense? Because really what we solved for was the width. Okay, and to solve for the width, the max width, okay, is solving for h. So just translating it over to the problem. Okay, so what we answered so far of the problem, find the maximum area using the vertex formula. We solved for first the max width, which is the optimal width, which is h. Notice h is equal to negative 400 divided, 400 divided by negative 4 equals 100. Oh, you know what? I read the problem. I read the problem wrong. Okay, a farmer has 400 yards of fencing. I accidentally wrote down 200. Okay, but that's okay. It's the same setup. So for the problem that I've been doing here, instead of starting off with 400, I started off with 200 yards, which is okay. It doesn't change the problem too much. It's still the same math and structure. Okay, so my apologies with that. But otherwise, what I want you to understand is that solving for h for this problem is me solving for the max width. So now if I actually want to know what the max value is, I would have to plug it back into the equation. So right now what I want to show you is this is we solved for width. Okay, width is 50 here, right? It's saying this is going to give me my max area, 50 here. And then this is my length and this is my length, right? However, this side we don't worry about, right? So we're not worried about that length because there's a river there. So no fencing over there. And then again, how did we write L? L is equal to what? 200 minus 2W. So instead of writing L, I could also write 200 minus 2W. Which, what is W? I know what W is. W is equal to 50. So I have 200 minus 2 times 50, which is equal to 200 minus 100, which equals what? 100. So for this problem, my length is 100. All right, and that makes sense. Why does it make sense? Because again, how many yards of perimeter do I have? 200. Well, to the problem I just made up, because on the homework, I mean on the practice packet, I accidentally started off with 200 instead of 400 because I misread the problem. But again, we're going to continue with this logic. I changed the problem a little bit in this example, okay? But this makes sense because again, how many yards of perimeter did I have? 200. So the most efficient way to wrap around this area is to make the width 50, 50, and the length 100 yards. So 50 plus 50 is 100 plus 100 over here is 200 yards. So I've used all my perimeter and I've used it with the most efficient way to cover the most area. Okay. Does that make sense? So now to find out what the actual area is, there's two ways really to do it. So how do I know what area is again? Area is equal to length times width. So I basically solved for area. I solved for the length by just plugging in 50 for what length equals to, right? And I plugged in 50 there. Width is 50, width is 50. And length is equal to 200 minus 2 times 50, which is 100. So I can do just 50 times 100, and I will get what is that, 5,000? Area equals 5,000. So that would actually be my max area. So I can do it like that. And it's not just 5,000, it's 5,000 yards squared. This is just yards, right? Because I'm doing yards times yards. If I do yards times yards, then I have yards squared. Sorry, that looks messy, but that's 2. Okay. Or what I could do is I could still use my knowledge of vertex, HK, and plug in 50 back into the equation. So I'm going to go ahead and do that too. So that way you have 2 ways to solve for area. So if I know my max area is when the width is 50, I could solve for max area by actually plugging in 50 to my area equation. -2 times 50 squared plus 200W. 250. 200 times 50. And this should also get me the same answer, 5,000. So we're going to double check. So 50 times 50, let me pull out my calculator, but I believe that's 2,500. 50 times 50 is, yes, 2,500. Again, order of operations, what comes first? Exponents. So that's why I'm simplifying this before I multiply by -2. 2,500. So I got to do exponents first, then multiply by that -2. Plus 200 plus 50, 200 times 50, which is 10,000. Is that right? Okay. Then -2 times 2,500 is -5,000 plus 10,000. Look at that. I got the same answer. What's -5,000 plus 10,000? Oh, it's just 5,000 yards squared. Okay, so there's two ways to solve for that. So I could solve for HK, and what I'm still answering both questions. What's the max width? Max width is when width is 50. What's my max area? Oh, that's just plugging in 50 back into the equation. Now that I know my max width is 50, my max area is just me plugging in 50 back into the area equation. Or once I solve for H, I could just plug it into my visual. You can draw out the problem, plug in 50. Okay, 50's here, 50's here, and then length is equal to 200 minus 2w, so 50 is also right here. So now 200 minus 2 times 50. Okay, length is 100. So 50 times 100 also gives me my max area, just on my knowledge of length times width. So completely up to you. Cool. So now moving on to number 2. Is the quadratic formula. Okay, so again, I have a quadratic function when I have something in the form ax squared plus bx plus c. So technically, with this problem, I could use the quadratic formula if I want to, because this is in the form ax squared plus bx plus c, and my c, just like I wrote here, is to, if I'm missing my c value, that just means that it's 0. Just like if I was missing my b value, it's just 0. Okay? So going back to this problem, let's use the quadratic formula for this problem. X squared plus 4x plus 8. X squared plus 4x plus 8. Okay. I don't want a highlighter. Okay. X squared plus 4x plus 8. Y is equal to x squared plus 4. Okay, so now, since I'm going to use a quadratic formula, I have to label each value. So x squared is 1. A is 1. The number in front of x squared is 1. It's just not there, but there's a 1 there. That's the coefficient of x squared. The number in front of x is 4, so that's my b term. And then my c term is 8. Okay, now, before I do the quadratic function, what I need to know first is the discriminant. Okay, discriminant is a part of the quadratic function. So let me the quadratic formula. Let me write down the quadratic formula, which is x is equal to b negative b plus or minus the square root of b squared minus 4 times a times c. Not 4 plus a plus c, 4 times a times c. All over 2a. Okay, so the discriminant is just this guy. Okay, so let me just write that down. X is equal to negative b plus or minus the discriminant. Okay, so everything inside the square root, inside, not including the square root, just inside the square root is the discriminant. So I'm just going to write that down. What is discriminant equal to? Oh, the discriminant is equal to whatever's inside the root. So b squared minus 4ac. That's it. Okay. So I can get these values. I already have them labeled A, B, and C. All I have to do is plug them into this formula so that I can get the discriminant value. So the discriminant is equal to, and then before I plug in values, I like to put parentheses around the letter, the variable, so that I don't mess up the problem. That way I know what I'm plugging in. Okay, and also the parentheses remind me that I'm multiplying these terms. Okay, so what's my B? 4. So I'm going to plug in 4 there. What's my A? 1. So I'm going to plug in 1 there. What's my C? 8. So I'm going to plug in 8 for C. Okay, now again, order of operations. What do I do first? I want to do my exponent first. Before I start multiplying, I got to do my exponent first. So 4 times 4 is 16. So I've simplified the exponent. And then I still have 4 times 1 times 8. Okay? So you could either do 4 times 1 times 8 and then subtract that value, or you could do negative 4 times 1 times 8. However you want to think about it. Okay? So I'm going to do negative 4 times 1, that's negative 4. And negative 4 times 8 is negative 16. I mean, negative 32, sorry. So I have 16 minus 32, basically. So my discriminant is equal to negative 16. Okay, the reason that before we even use the quadratic formula, we solve for the discriminant because it already tells me a lot about my results. So the whole point of using the quadratic formula is so that I get a value x equals, we're solving for x, and x equals. Okay? Why do we solve for x? Because these are going to be my x-intercepts. I'm going to get x comma 0 and x comma 0, which is the same reason as why we factor. Okay? Because these are points that I could plot on my graph that are going to be on my x-axis. Okay? Because again, reminder, we have a quadratic function. So again, I'm either going to have a u pointing up or a u pointing down. And notice whether I have a u pointing up or u pointing down, it's going to cross my x-axis twice. Okay? Or sometimes once. That's why we solve for the discriminant, so I know how many times or what kind of x values I'm going to get. All right, just like I could solve for my vertex for a quadratic function, I could also solve for my x-intercepts. Okay? That's why we use the quadratic formula. And then it's important to know what kind of x values I get. Okay? That way I'm prepared to draw the graph as well. So now, how do I know what kind of x values I get? Through solving for the discriminant, which we just did, and then what kind of value did I get? Okay, I solved for the discriminant and I got negative 16. So what does that mean? So now I have to look at my chart. That's why I provided you guys with the chart. And it says, look, the discriminant tells us the number of solutions and the type. Okay, so like I said, we get x-intercepts. So we got to figure out, okay, how many x-intercepts do I get and what kind of x-intercepts do I get? If I have a positive and perfect square, okay, so again, what value did we just solve for? I got a negative 16. So it's not positive and much less the perfect square. Again, I'm not looking at this one because, again, it's not a positive. Negative 16 is not a positive number. Negative 16 is not 0. So right away, I know I'm not going to. This one is irrelevant. This one is irrelevant. This one is irrelevant. I have a negative number, so I'm looking here. Okay, so negative 16 is negative, so for sure, that means I have 2 solutions, okay? And these solutions are complex, okay? Which means I have I. They're not real. So actually, even though I'm going to get 2 x values, these x values are not even going to be on the graph, which is okay. Again, this problem's not even asking me to graph. I just have to understand what the discriminant means, okay? So just by me knowing how to read this little chart tells me that I understand what the whole point of the discriminant is. The discriminant's job is just to tell me the number of solutions and the type. So that's all I need to know, that I'm going to get 2 solutions, and these solutions are complex, so they're going to have an I. So that's what I should get in my final result. So 2 solutions that are imaginary, not real. They have I. Okay, so now I'm going to use a formula. Now I'm going to actually do the quadratic formula. All right, we already did this math. We did it when we solved for the discriminant. So that's why I put a D there. So all I'm going to do is I'm going to plug in D there because I don't want to do that math again. I already did it. Okay, like I said, the discriminant is already part of the quadratic formula. So we already got done with at least a lot of the math. Okay, right there, at least with the discriminant. So I have x is equal to negative b square root the discriminant, right? B squared minus 4ac. What do we get? Negative 16 all over 2 times a. Okay, now I just got to worry about plugging in b, right? That's why I'm putting parentheses around b, and I'm putting parentheses around a. So now let me erase the inside. What's b again? And what's a? I don't know. Let's see. B is 4 and a is 1. So I got to plug in for b 4 and for a 1. So now what am I left with? X is equal to negative 4 plus or minus the square root of negative 16 all over 2. Okay, so now we could simplify this guy. This is where I'm going to see the I. All right, so this needs to be simplified so that we could actually see the complex number. So how do I simplify negative 16? Oh, I notice I want to take out that negative 1. So what negative 1 times what gives me 16? 16. Okay, so the reason we separate that 16, we separate the negative 1. So this square root of 16 is the same thing as square root of 16 times negative 1, right? 16 times negative 1 gives me negative 16, so I'm just separating it a little bit. All right, so the reason I want to separate the negative 1 is because the square root of negative 1, this is equal to I. This is where we get the imaginary number. Okay? So this is equal to I. Okay, now I can simplify this side. What's square root of 16? Oh, that is 4. So the square root of negative 16 is just equal to 4I. Okay? And then x is equal to -4 plus and minus of 4i over 2. So that is two separate solutions. -4 plus 4i over 2 and x equals -4 minus 4i over 2. So notice I do have two solutions for x, and these both solutions are complex. Why are they complex? Because I have an I value. Okay, this could actually technically be simplified even further, but we don't really need to worry about that. If you got up to here, that's perfectly okay. The key takeaway here is that first we have to solve for the discriminant. The discriminant tells me the number of solutions and the type of solution I get. The only way I understand how to translate the discriminant into basically words is by looking at the chart. So once I solve for the discriminant, I should look at the chart and see what kind of solutions I get and how many solutions I get. Okay, well, I have a negative discriminant, so that means I have two solutions that are I. So now I plug in the discriminant back into the quadratic formula. I fill in the other values that are missing, which in this case was B and A. Now we see clearly why we translate the discriminant, because once I'm done solving for the quadratic formula, how many number solutions did I get? 2. 1, 2. What kind of solutions are they? Oh, they're not real because I have i's in them. Okay, so once I actually fulfill and complete the quadratic formula, it should justify what the discriminant tells me. Two solutions that are I. Okay, yeah, I got two solutions that are I. I'm just confirming what the discriminant already told me. And these are the solutions. Okay, so that's all the problems. I hope that offered some clarity in case you still had questions with that. But that is it.